Hello, this is Paweł from DevOps Codes. Welcome to the next lesson about AWS and DevOps. Today we're gonna continue our journey about creating VPC. Last time we created a new VPC using Web Console. Today we're gonna learn how to make it with Terraform code using Terraform modules. Please join our Facebook group, DevOps Codes Academy. We are building a community where we can share knowledge between ourselves and we can learn together. You can find a link inside our video, inside the description section. So if you have any questions, of course, drop a comment under the video. Don't forget to subscribe to our channel. Don't forget to leave a like. And let's jump to the console and build a new VPC using Terraform code. Okay, we are back in the browser right now. And let's make a quick reminder. We will take a look how the VPC should look like. So we will have a VPC. We will have some private subnets and public subnets inside. We can create 2 private and 2 public today. We will have a root table. We will have a NAT gateway. We will not create a bastion host at this lesson. But what I want to show you, how we can easily create a VPC using Terraform module. If you don't have our repository yet, you can find it on GitHub and also in the description of this video. So this is the latest code that we have when we were trying to create a EC2, S3 backend and CloudFront. Okay, let's find out how to create a VPC module. Working with Terraform and using modules will allow us to reuse code written by somebody else. So you can see here that we have an author and Anton Babenko, the source code, so we can find the Terraform code on GitHub, and we can see there will be a lot of resources written in Terraform, a lot of logic. So this is very advanced way of writing code. But for us, we can just take a look into the README file and we can see that there's an example of using this module. All right, let's take this part of the code. We will not go through all of inputs, almost 200, right? We can do a lot of configuration inside the VPC, but of course we are starting with the simplest things. Okay, let's create a new file, vpc.tf. We can use the module. We have my DevOps codes here, comment, name, all right. Or we can use my DevOps codes VPC. Remember, some resource, they need a unique name. Here we will just attach tags to our resources in VPCs, so they don't have to be unique in our case. And we can have a CIDR. So CIDR is a block of network that will define how many IPs we will use in our private network. We will have availability zones. We will have CIDRs for private subnets and for public subnets. We will not go through all of the details right now, but let's make it as simplest as possible. So if we go to our main, we see that we are using AWS in region EU Central 1. So let's take it here and exchange EU West 1 with EU Central. We will have only 2, we don't need 3 at this point. Of course, for production, it is recommended to use 3 availability zones at least. However, 2 is enough for our case. So /24 will say that we will have in each subnet from 0 to 255, right? That's the range of it. 24, it's easy to remember. 24 and 25 for me. That's how I always make it. So, and when we go out of this block, then we can start from another number here, right? So maybe let's show you just a little bit quick SIDR calculator. There's a lot of online tools that they will help us to see. If we choose the SIDR, you will see that the first IP will be 10.0.0.0 and the last IP will be 10.0.0.255, and we will have maximum 256 hosts. We have to remember that Amazon is taking 5 of them. So if we change here, see from 10.0.1, right? So this is how it works. And our whole VPC will be bigger because we use /16. So you can see it will be from 10.0.0.0 to 10.0.255.255, which gives us more than 65,000 hosts. Okay. We want to enable NAT gateway. We remember that NAT gateway will allow us from the private subnets to interact with internet. And remember, NAT gateway is a resource that will charge us, so be careful here. And we can have another flag here, and let me show you how we can see. I already know that this module, if we leave it as that, probably it will create multiple NAT gateways. Let me see, single NAT gateway, right? So this is an input, should be true if you want to provision a single shared NAT gateway across all of your private networks, and the default is false. So we want to have only one NAT gateway. It will be cheaper for us. All right, true. Enable VPN gateway. We don't want it. We can delete it. Tags. We have any predefined tags here? Not yet. So we will delete tags here and we will make default tags very soon. All right. Let's see. Terraform plan. Oh. All right. Terraform. I have to change my AWS profile. Academy. Terraform init. So we are checking the state. We are installing the module that we have defined. If we don't define, oh, sorry, this is the provider, AWS, but we will see also here that Terraform should install the VPC module. It's here, right? So we didn't define the version. It's pulled the latest one. We can define it here. Version 3.18, let's see, 0, Terraform init, and you see that now it's interacting with 3.18.0. It's very good practice to put version here, so we will avoid any sudden changes. We will control the version of our code, then we can always find the latest version here. You can check all. Also, in the source code, we will see tags, and tags also pointing to different version of the code. You can go to releases, and in releases you will see the description of changes made in each of release. So just to make a quick 3.18, some features, assets, right?
If we make a 3.0, usually there will be some, no, don't have it, 3. Oh, maybe it's not visible anymore. I wanted to show you that if we jump from 2 to 3, usually there's some breaking changes, and it will require from you to do some changes in your code. Okay. Let's do the plan. And we see that it wants to create all the stuff that I had here. It will create CloudFront. If we don't want to create this CloudFront at this moment, we can comment it out. S3 bucket, can also comment it out, make plan again. Okay, now we have 16. Terraform will create Elastic IP. This is the public IP attached to NAT gateway. We'll have an internet gateway allowing in and out. We will have NAT gateway itself. We will have root for private NAT gateway, root for public one. We will have root table association with subnets. We will have a subnet. We can see the seed block here. And the VPC itself. Let's do Terraform apply. I will go quickly to the web console. Okay, yes. VPC, we go to Central 1 in Europe. And we see that VPC is already created. Right, Terraform is performing actions for us. Root tables, we can see subnets, 2 private, 2 public. Seed blocks are correct. We will have root tables, and the private root table, still NAT gateway hasn't been created. We can see that NAT gateway is creating, so it's nothing here, but public subnets, they will have already 0.0.0.0/0 pointing to internet gateway, which has been created. And when NAT gateway will be created, we will have a record pointing to it in our private root table. This lesson I hope to be quite quick. We will just finish this VPC and we will destroy it afterwards. Do not AWS charge us for NAT gateway. In next lesson we will come back to load balancer, application load balancer, to create and put it into the public subnets, because we will want to have it a public one. And we will continue our journey to create a simple application with S3 bucket together with CloudFront for static frontend, which will be sending requests to our load balancer, and load balancer will be redirecting to the backend containerized in Docker. We're gonna also learn a little bit about Docker here. All right, NAT gateway created and root table, the record also created. If we refresh here, private roots, we see that here we have a 0 pointing to NAT gateway. So with this configuration, our resources in private subnets, they will be able to pull some updates, patches, or whatever we want to from the internet, but nobody will be able to connect to those resources, let's say to our backend code from the outside. So it's a secure way. And resources in public subnets with public routing tables will be accessible via their public IPs from the wide internet. Okay, that's nice. Let's perform Terraform destroy. This is the magic of infrastructure as a code. We spent some time to write it, but later on, only with one command at the very end of our class here, we will be able to create the whole environment for the 3 web tier application for front-end, backend, and database within one command, which is perfect, right? Also, I always remind about that whatever is written as a code, it's visible for other engineers. So if anybody else who has experience in Terraform, he will take a look into that code. He can perform Terraform plans, see if there were any changes made. And it's easy to hand over between engineers. Okay. Table is gone. Subnets are still visible because we are waiting for NAT gateway to be deleted. And it's deleting. Internet gateway is still waiting for NAT gateway. And VPC, of course, will be deleted as last. All right, guys, thank you very much. I'll just wait until everything is done. Don't forget to subscribe. Don't forget to put any comments, likes, and visit our Facebook group, DevOps Codes Academy. See you in next lesson. Bye-bye.